Hello everybody. Today we are talking about remainders. Remainders are one chapter very closely related to integers. So we can take this as an extension of integer number properties. All right, let's begin. Let's see the concept of remainders. What is a remainder? Well, the concept of remainder has to do with the inexact division. When you divide one number such as 45 by a number like 6, well, it simply doesn't fit, right? You can't find an integer that divided by, when you divide 45 by 6, you get such an integer quotient. You can get as much, a quotient such as 6, because 7 times 6 is barely 42, but you have some left over, which is 3 units. So in this uneven division, you can express the relationship between the dividend, right, and the divisor. In this way, the dividend equals the divisor multiplied by the quotient plus the remainder. So, in the case of 46 or 45 and 6, 45 would equal 6 times 7 plus 3. This left over here is called the remainder. And to be such, it needs to be less than the divisor. So we're talking about integers again. Okay, all these numbers are integers. Let's talk about the remainder structure. Okay, a typical question could mention the remainder when integer x is divided by 5 is 2. How should we read or interpret this? Well, in the same way we do when we use the division of one number by another who isn't exactly a factor. Okay? So in this case, identify the dividend. What's the dividend here? Integer x, right? So that integer x should be a multiple of 5. That means 5, the divisor, multiplied by some other integer, plus the remainder, which is 2. So that is the way to be to read or interpret this remainder structure. Remainder when integer x is divided by 5 is 2 means that the integer x equals a multiple of 5 plus 2. And you can write this like this expression, x equals 5 times q, where q is an integer quotient, plus the remainder 2. Or, if you want to make it more succinct, and you just want to have nothing to do with the quotient, which in most problems you don't actually need to deal with, you can just write it like this. X equals a multiple of 5 plus 2. Okay? So, let's talk about the first property of remainders. The first property of remainder says that the multiple of the divisor plus the remainder can be rewritten as a multiple of a factor of the divisor plus the same remainder. You can go down to the factor that better suits the question, but you cannot go up to a multiple. How is this understood? Let's see this by means of an example. When the integer x is divided by 36, the remainder is 10. We know now that we can represent x as a multiple of 36 plus 10, which in fact can be rewritten as this. X is a multiple of 18 plus 10. How is that possible? Well, simply because since 36 contains 18 an even number of times, so any multiples of 36 should be also a multiple of 18. So saying that x equals a multiple of 36 plus 10 is the same as saying that x is a multiple of 18 plus 10. Okay? And it will also be the same to say that x is a multiple of 12 plus 10, because a multiple of 36 is also a multiple of 12. The interesting thing here is that you can reinterpret these structures here as the remainder when x is divided by 18 is 10, and so on with the next example, that is the remainder when x is divided by 12 is 10. So you can see you can use this property to establish the remainder of the original number, the original dividend, regarding a divisor that is a factor of the original divisor. So can we do this with other divisors of 36? Yes, we can. For example, I can say x equals a multiple of 9 plus 10. You know, for the same reason I said so in the two former cases. But saying that x divided by 9 is a multiple of 10 doesn't really mean that 10 is the divisor when you divide x by 9, because 10 is greater than 9. But if you split up 10 in the sum of 9 plus 1, now you can see that a multiple of 9 added with another 9, it's still a multiple of 9. So in the end, x will be a multiple of 9 plus 1. Thus, 1 becomes the remainder when you divide x by 9. Okay? Let's see another case. If x is a multiple of 6 plus 10, since 6 is also a factor of 36, what happens now? You can split up 10 into 6 and a 4. So, you can put this together. Multiple of 6 plus 6 is still a multiple of 6, and the remainder of the division would be 4. And what would happen if we did this with 4 as a new divisor? Since 4 is also a multiple or a factor of 36, you can say that x is a multiple of 4 plus 10. Since 10 you can split as 2 4s plus 2. That is to say, here you have another multiple of 4, which added to the multiple of 4 on the left, you still get a multiple of 4 plus the remainder. Okay, so this property can be used in that way. But from knowing this original fact, you can't ever say what would be the, for example, remainder when you divide x by a multiple of 36, such as 72. The remainder would be unknown, right? I don't know, because I cannot go up to a higher number. Only can do this with a factor of the original divisor. Let's talk about remainder property 2. Remainder property 2 teaches us that when the same number is expressed in two different ways, like the multiple of two different divisors, but with the same remainder, you can express a number also as a multiple of the least common multiple of the two divisors plus the same remainder. Here, let's see an example. If the number of books on a shelf were to be arranged in groups of 6, the remainder would be 3. If the same number of books were to be arranged in groups of 8, the remainder would be 3. how many books are on the shelf if the number of books is between 25 and 40? Well, you can tell here that from the first statement in this problem, and the number of books on a shelf, you can consider that when it is divided by 6, you get a remainder of 3. So it's a multiple of 6 plus 3. And you can also divide it by 8 and get the same remainder. So it's also a multiple of 8 plus 3. See, here you have two remainder structures with the same remainder, 3. You can combine the two structures into one single structure where you have a multiple of a new divisor, and that new divisor would be the least common multiple of the two original divisors. So in the case of 6 and 8, that new divisor would be 24. Since now you know that n is a multiple of 24 plus 3, the same remainder, then you can quickly situate the value of n in the interval given. Because you know that n must be a number greater than 25 and less than 40, so possible values for n would be a multiple of 24 plus 3, which could be 0 plus 3, 3, 24 plus 3, 27, 48 plus 3, 51, and so forth, right? But from those values, you can see the only one that fits this interval here is just 27. So that must be the answer to the question. Okay, so you can use this property in this way to combine two remainder structures that have the same remainder. Let's see property number 3. When two numbers are expressed as being multiples of the same divisor, you can add or multiply them. Well, how do you understand that? Well, let's say that we have, for example, numbers n and m. So, if you can express n as a multiple of x plus a certain remainder a, and m as a multiple of the same divisor plus another remainder b, you can quickly establish what is the sum like or what is the product like. Just by setting the same multiple of that common factor for the two numbers plus a remainder that be the sum of the two remainders. And in the case of product, you just multiply the remainders. So let's see an example here. If the remainder when the positive integer a is divided by 8 is 7, and the remainder when the positive integer b is divided by 8 is 5, what are the remainders when the following are divided by 8? And we have several expressions based on a and b. So first of all, what is a like? 8 is a multiple of 8 times or plus 7, right? While b is a multiple of 8 plus 5. So you can see that these are the two numbers here. How can we express the sum of the two numbers? A multiple of 8 plus 7 plus a multiple of 8 plus 5. So you just add the remainders, which is 12. And from this, you know, you can split the 12 into an 8 and a 4. So the final remainder would be 4, right? A plus b, when you divided it by 8, becomes 4 as a remainder. Now, what about the product of a and b? If you multiply these two, you can just express as the same common multiple of 8 plus the product of the two remainders, which gives you 35. But here you can split 35 into 32 plus 3. You know, this is the remainder when you divide 35 by 8, right? You just get 32, the closest multiple of 8 to 35, and the remainder would be 3. So in the end, this multiple of 8 plus another multiple of 8 is just yet another multiple of 8 plus the remainder 3. You can use also the properties to find how an algebraic expression, out of these two variables or integers can have as a remainder, in regarding the original divisor, which is 8. For example, 2a plus 3b. If I divide that by 8, what's the remainder? Well, you can express 2a plus 3b as a double sum, right? A plus a and b plus b plus b. So if you apply the addition property, so you have that first would be a plus a would be a multiple of 8 plus 14, which is the sum of 7 plus 7. And b plus b would be a multiple of 8 plus 5 plus 5 plus 5. So that gives a multiple of 8 plus 29. And 29, when you divide it by 8, the remainder is 5. So that's the final remainder, right? In the case of a squared and b squared, you can also see this as a double product. A times a plus b times b. So a times a will be multiple of 8 plus 49, and b times b would be a multiple of 8 plus 25. You just put together these two quantities, you get 74. And 74, when you divide it by 8, gives you a remainder of 2. So that's the final remainder of the expression regarding 8. Let's check property number 4. Okay, property number 4 says that a multiple of a divisor plus a remainder can be expressed as the same multiple of the divisor minus the complement of the remainder. What does this mean? Let's see through an example. Let's say we have a number that can be expressed as a multiple of 10 plus 7. Let's say, for example, number 97, all right? So we know that this number can be expressed as a multiple of 10, which in this case would be 90, plus the remainder, which is 7, of course. But you can see that 97 is also the next multiple of 10, which is 100. Take away 3. Yes, so this is how we verify that a multiple of 10 plus 7 is the same as a multiple of 10 plus 3. Of course, here, these two multiples of 10 are different, right? They're not the same multiple of 10. But here we understand that this number here, 3, corresponds to the difference between the divisor and the remainder. This is what we call the complement of the remainder. The difference between divisor minus remainder. That's it. What do we use this property for? Well, sometimes it facilitates the application of property number 2. Example, if the positive integer n has a remainder of 5 when divided by 8 and a remainder of 9 when divided by 12, what is the remainder when n is divided by 4? Well, here, this is interesting. What we can see here is interesting. Take a look. N has a remainder of 8 when divided by 8, and a remainder of 9 when divided by 12. So these are the remainder structures that represent this statement. But now we can see that there is no common divisor nor a common remainder, so we have no way to apply any of the previous properties. But if I express each of the remainder structure in terms of the complement of the remainder, for example, if you have a multiple of 8 plus 5, it means that it's a multiple of 8 minus 3 because 3 is the complement of the remainder 5. So the same goes for the other structure. A multiple of 12 plus 9 equals a multiple of 12 minus 3 because 3 is the complement of the remainder 9. So now it looks like we've uniformized the remainder, even though it looks negative, right? But if we apply the second property, we can use that same so-called negative remainder to apply property 2 and establish that n should be a multiple of the least common multiple of the two divisors, 8 and 12, minus 3, that is the same remainder. But here we can convert now to the expression that shows the true remainder, because if 3 is the remainder when you divide, is the complement of the remainder when you divide by 24, that means that the true remainder should be 21, okay? Because 21 only is missing 3 units to get to 24. So the original, the actual answer is 21.